Hi folks, this is the second video for section 4.1, Sampling and Surveys in AP Statistics. If you didn't watch the first video, you should absolutely go and watch that first, because it leaves off exactly here on this page where I asked you guys to consider how to use random number generation to complete these simulations. Before I actually give away the answers to that, I want to circle back to something that I failed to mention. One of our objectives last section was to talk about how to obtain a random sample using slips of paper, technology, or a table of random digits. We covered the last two, and the first two is kind of exactly what it sounds like, where if you think of like a raffle or something, people write their names, or everyone gets a number that's on a ticket, and then the corresponding ticket or name or whatever is selected from like a big bucket or something. And the idea is that the bucket is randomized somehow, usually by being shaken up, right? So AP graders decided that if people were saying pick a name or a slip of paper from a hat or whatever, that this was insufficient and that the students weren't understanding, or at least conveying, that there was randomness involved in this. So they gave some clear phrases that could be used to indicate randomness, and one of which was shake vigorously. So that's right, it's become kind of a meme in this class in the last couple of years that if you don't include shake vigorously when you're choosing numbers from a hat or slips of paper from a bucket or whatever it is, you're not going to get full credit. So please remember to shake things vigorously if you are selecting from it, and that'll constitute randomness. Another thing is, I meant to mention this last class, just a notion of how randomness works with technology. The first year that I taught this, I was demonstrating like how to use this. Randint 1, 100, 10. It's going to select 10 digits from 1 to 100. Sorry, 10 integers from 1 to 100. And I think I concluded by saying, like, here's our 10 integers. I guarantee that you won't get the same thing that I got just because there's so many possible options. And before I'd finished the next sentence, I already had a couple kids raising their hand and being like, well, I got literally the same thing as you. And that got me thinking, there's no way it could have happened due to coincidence that they got the same 10 integers. And it started getting me thinking about how technology handles the notion of randomness, quote unquote randomness. Well, it really doesn't, because technology runs on algorithms, and that's not random at all. There's some sequence to why it works the way it works. And I kind of recognized that I was getting the thing I was getting because I was using an emulator, and they were getting the things they were getting because it was their first time using this function on their calculators. So what I suspect is happening behind the scenes here is that the random integer generation is using more or less a random number table or random digit table, and starting at some point, and then it's going from there. So it's not really random, not really. Actually, it's the opposite. It's very predictable. We could probably use that to our advantage and conclude what the random digit table is saying, or what's going on behind the scenes. Whoops, you saw this already. But know that it's, for all intents and purposes, random enough for us to be satisfied. So anyway, let's talk about these simulations. I need to simulate the results of 8 coin flips. Suppose I don't actually have a coin, but I have something that could produce a 50-50 one thing or the other. Anyway, if you have a calculator, you do. In fact, there's a calculator app for flipping coins on most of your calculators, I think, and I assume it works exactly like this, just with a very cute UI that goes with it. What we could do is we could assign one side of the coin heads a 1, and then the other side of the coin tails a 2. Or, if you're thinking binary, we can go 0 and 1 also. And then if we're flipping 8 coins, we would want 8 instances of 1 or 2, or 0 and 1. So randint 1, 2, 8 would produce that for us. It might produce like 1, 2, 2, 2, 1, 1, 2. I forget how many numbers I said already, but remember that each of those would be indicative of a heads or tails. And even the coin flip simulation that I did on the summer work videos that everyone definitely watched, those probably worked in a similar fashion as this. So number 2 is actually something I had to do as well when I was hosting Super Smash Bros. Tournaments back in the day for one of the clubs that I was the advisor of. Except I chose nicer numbers. I have a Super Smash Bros. 4 tournament with 32 participants and need to generate a bracket for the first round. What we could do is we could assign everyone a number, each player a number, 1 to 32, or again, if you feel like going this way, 0 to 31. I could randint no repeat 1 to 32, and what this essentially does, I know usually there's a third number here, but if I close it at 2, what this does is it basically randomly generates an order from 1 to 32. So it might spit out like 17, 3, 4, 5, 31, 26, and it'll go all the way with the 32 digits and essentially reorder them. So since I have a randomized order, what I could do is just match them in adjacent pairs. So I forget what I said already, but if the first two numbers are like 7 and 13, I would match those two, and then if the next two are like 8 and 26 or whatever, those get matched up. And this works out nicely because there's an even number of numbers here. So everyone would get paired. If this were something unclean, like if this were an odd number, like 33, then I could just make up an arbitrary rule, like the last number on the list gets a bye for the next round, or something like that. For number 3, I want to model the spread of a disease in New Jersey rabbits. Each member of the initial population has a 20% chance of being infected. Poor rabbits. How do I simulate the infection rate of a hypothetical sample of 30 bunnies? Okay, so what we need to be very careful about, and we can kind of connect this to the side note on the bottom, is that we don't want to pick 20% of the 30 bunnies, aka 6 bunnies, are infected. We don't want to pick 30 bunnies and ensure that 6 are infected. That's not how it works. What we want to do is say that each individual bunny we have has a 20% chance of being infected, which may result in 6 infected bunnies, or it may result in not 6 infected bunnies, just due to sampling variability and how probability works. So what we could do is we could say each bunny is randomly given a number, 1 to 5 or 0 to 4 if you feel like starting at 0. We could designate one of those numbers as infected. I'm going to go with the first example and say 1 is infected. If a bunny gets a 2, 3, 4, or 5, they're not, because 1 out of 5 is a 20% chance, so that'll adequately simulate that. What I would do is I would do this process where each bunny gets a 1 to 5 30 times, and what this will do is it'll spit out 30 numbers, each 1 to 5, and each of those numbers represents a bunny. Every bunny that I have with a 1 is infected, every other number is not. So by the end of this, I would want to count the number of 1s out of my sample of 30, and that would tell me, if I divide by 30, the proportion of infected bunnies in this sample. On the bottom, do I expect the sample proportion to be 20% just because the population is? And the answer is no. I wouldn't expect that to be the case, but I don't know if it's going to happen, like I said, due to just sampling variability. The population proportion may not equal the sample proportion, but it might. But also there's always that plus or minus due to just the probability of the event. So last time in the last video, we also talked about an SRS and how that's like the ultimate form of sampling in terms of getting results that are indicative of a population, but there's other things that'll work too depending on what our needs are. So there's something called a stratified random sample, and there's something very similar called a cluster sample. So let's talk about each of these things, and I want to make sure that by the end of this you can distinguish the two from each other. In a stratified random sample, I would classify the population into groups of similar individuals called strata. Then we would choose a separate SRS in each stratum and combine these SRSs to form the full sample. So an example of this, I could divide a population by gender or age or region, etc. Then I could select some members from each. So suppose I want to know how the population at Del Val feels about the way that we're handling social distancing and like just the way our school year is going this year in terms of obeying protocol and actually having decent educational lessons. So what I could do with an SRS is there's like 8, let's pretend just for ease of access here, there's 800 of us at Del Val, 800 students. What I could do is I can take an SRS of however many of those out of the total 800, and then that would be what it is. If I wanted to do a stratified random sample for some reason instead, I could break it up into grade levels instead. I could randomly sample from freshmen, and randomly sample from sophomores or juniors or seniors also. I shouldn't say or, I should say and. I'd be randomly sampling from each of those groups. This is best used when I'm trying to have equal representation across all subgroups. This most commonly occurs in experiments. In fact, I saw an AP question that was talking about, this was last year, an experimental design question that was saying something along the lines of, there was a drug, and we weren't sure how, or the producers weren't sure how it would affect men versus women's because the drug included some hormones in it. So instead of doing an SRS of a population to gather test subjects, they wanted to use a stratified random sample instead of an SRS in order to ensure that there was equal representation between men and women, because they wanted to have similar sized sample groups to compare the results in. However, usually if our groups here are not equally distributed, sometimes an SRS is better for capturing the total population, but if that's not the objective, if we are looking for equal representation, then a stratified random sample is good for that sort of thing. Along a similar vein is called a cluster sample. They divide the population into smaller groups called clusters. There should be groups, whoops. We would choose an SRS of the clusters, and then we would select all individuals in the chosen clusters to include in our sample. So an example of this could be if I divide homes of Wapakong by street, select 3 streets, and use data from all households of those 3 streets. This is best used when the subsets are reflective of the population. So I can almost assuredly tell you that this is not going to occur most of the time in cluster sampling, or there's ways to do cluster sampling wrong in a way that won't get you data that is indicative of the population. Because no matter what I'm trying to figure out about Lopat, the 3 streets that I'm selecting from a random sample are probably not diverse enough to totally capture Lopakong's general feeling or data. So in terms of comparing these things, yes, both of them involve breaking up into subgroups. One of those subgroups are called strata, the other is called clusters. But in terms of how they work, I kind of like to think of it like, suppose I'm trying to get a poll for what proportion of schools are doing virtual learning this year. Again, it's 2020, the worst year ever so far, if you're watching this from the future. And suppose I want to do this. I could break up the United States into its 50 states. I could do it that way, and I could let each of these subgroups be either strata or clusters, depending on what I do next. So if my idea then is to go and select like 50 schools from each of the states, that would be considered a stratified random sample. I am breaking into subgroups and choosing an SRS of each stratum and combine those into the entire sample. If, however, instead of selecting 50 from each state, what if I just say, like, I'm going to select 4 states at random, SRS of 4 out of the 50 states, and then I'm going to look at every high school in those states? Well, that would be a cluster sample. I would imagine that actually be worse than a stratified random sample in this instance, but maybe they're actually, I would actually say they both, in this situation, are definitely inferior to an SRS, because this would kind of be like the whole House of Representatives versus Senate thing, where I guess the stratified gives equal representation to the states, but I mean, they're all different sizes and have different populations and everything. But in terms of distinguishing these two from one another, if we kind of accept that an SRS is the best, but go with one of these anyway, we should note that a stratified random sample can be summed up to be, we select some individuals from every subgroup, versus a cluster sample, which is we choose every individual from some subgroups. This is starting to sound like a Three Musketeers, like all for one and one for all sort of thing, but stratified is, again, some from all, and cluster is all from some. And the way that we choose these sums, there's randomness involved there as well. So again, there's times where each of these things are okay, and times where there really is no substitute to an SRS, but as we're going to talk about in the future, SRSs are really hard to pull off. Like, a lot of times we just don't have the means or resources to do it. So again, for another comparison here, take a second to pause this if you want to sort this out, but assume that we don't have to socially distance this year, and we have an assembly. Describe how you would use each sampling method to select 80 students for a survey. So suppose everyone's like in the assembly, and we have, I don't know what our auditorium actually is like, but suppose we have 800 seats. So suppose we have 200 like columns here, or sorry, not 200, 20 columns and 40 rows that we're kind of dotting, so that we have the first 2 rows up top and then the last 2 rows on the bottom, and then everything in between is the other 36 rows. Suppose we also situate our student body, we're pretending that there's 200 in each grade here, such that the seniors are in the front, they make up the front however many rows, and then is the all the way back to the freshmen in the back, they make up the last 200 seats. And if I want to try to find a good way to actually randomly sample from these using each of these methods. So there's different ways to conduct stratified and cluster samples, because remember, both involve subgroups, and we can break up the subgroups in different ways, but try to think of the best ways. Again, pause the video if you want to think through this on your own, but I'm going to proceed. For simple random sample, it's exactly what it sounds like. I would just randomly select 80 integers from a list, 1 to 800, without any repeats preferably. But if you don't have that function, then you just have to reselect a number every time you get a repeat. But that would do it. That would be a simple random sample where everyone has an equal chance of being chosen, and every group of 80 has an equal chance of being selected as well. Remember, that was the second criteria for qualifying as an SRS. If I'm talking about a stratified random sample, I could break up into 4 strata and just say that each of those strata are the grade levels. What I'd want to do if I'm trying to select a sample of size 80 and I'm breaking up into 4 subgroups is I'd want to select 20 students from each of those subgroups, aka 20 students from each grade, and then combine them at the end. I could do this by randomly selecting 20 digits from 1 to 200, ignoring repeats, doing the same thing with the sophomore list of 401 to 600. Recognize that the seat numbers here kind of correspond to the student numbers, and this is us assigning numbers to students. I could do that 4 times, and then I could combine at the end. The cluster sample is a little bit trickier. But I'm going to throw it out there that we can treat each column like a cluster, and we could actually do so pretty successfully. This means that there would be 20 clusters, because really there's 20 columns here, and they each have 40 seats, because that's how the math works out, such that when we multiply, we get 800 students. I could randomly select 2 clusters, because 2 times 40 is 800, and I could use all seats in each. Remember, that's how cluster samples work. All from sum. All the students from some of the columns. In terms of why we're letting a column be a cluster, and in terms of why this would give us actually indicative data, is that, or something like indicative data, is that each cluster is going to contain the same amount of freshmen, sophomores, juniors, seniors, just based on the way the seating in this auditorium is going. So because our clusters are like microcosms of the population, this is actually a fine instance to use a cluster sample. I'm going to carry on, but if you need to pause and ingest this for a little bit, I know it was a lot, that's totally fine. So we talked about the good sampling methods. We talked about like the ultimate, the SRS. The other ones were good in certain circumstances. There's also something called systematic random sampling. And it's, I'm sure you could guess what it is, or you've seen something like it before. It's when items are selected according to specific time or item intervals. So every kth minute or kth member, etc. I'm using K here instead of N because N usually refers to sample size. But anyway, you've probably seen this like getting frisked at the airport every 20th person or so, or like if there's testers who are working an assembly line, they can't test every single item that comes by, so they might grab one every 5 minutes or so. My friend Frank is an auditor, so since he can't peel through like thousands and thousands of documents for the companies that he's auditing, he might need to go every like, I don't know, every 100 documents or something and then scrutinize those. He actually made his job sound way cooler than I just did right now. But anyway, a lot of people use this one because it is definitely easier to pull off than an SRS. And a lot of times it won't be acceptable, but sometimes it can be. It can be acceptable if there's no patterns in the data or if the population is randomized. If it's not, then a systematic random sample isn't great. So suppose like I go to a restaurant, I'm trying to figure out what would be a typical, like how many customers we would expect there typically. If I'm using a systematic random sampling, depending on what my time intervals are, I might actually miss like the 12 o'clock lunch rush or something, and then I would consistently underestimate the amount of patrons they have on any given day. So because of that pattern in the data, that makes systematic random sampling not the best choice, but if we somehow know that there are no patterns, then it's fine. So that was an okay method. Now let's talk about some not okay methods. There's something called convenience sampling, which is just using data that's readily available or easily attainable. So for instance, I could survey the first 10 people to walk through the door. If I'm looking for subjects in that regard, I could select the 15 objects nearest in proximity, something like that. We actually talked about when we were dealing with the very first thing that I posed actually in one of the summer work videos was talking about bad stats and talking about how we want to know how lacrosse, or actually if you want to know how all athletes feel about like 1 versus 2 hour practices, a bad way to collect that data would be to sample the first 10 people, or however many it was, to walk into the locker room. That'd be a terrible idea, because there might be something about the first 10 that sets us apart. Or like, I had some students say that for their final project one year, where they actually had to collect data, they were going to go around their neighborhood and have that be representative of Frenchtown. Well, that's a bad idea. I mean, I get that you don't have to walk far if you go to your neighborhood, but what are the odds that on any given opinion piece, your neighborhood is somehow going to be indicative of the entire Frenchtown population? Probably not, just due to like, I mean, whatever geographical factors there might be. I assume if everyone's in the same neighborhood, they're of the same socioeconomic status or something close to that, and then that really fails to capture the variability in any population. There's also something called voluntary response, which is individuals choose themselves by responding to an appeal. So examples of this would be all individuals who answer newspaper ads or call into the radio station or pick up a phone. You see that a lot, like news on like, I guess Facebook's not really a thing anymore for your generation, but like Facebook polls, that only captures the Facebook demographic. And then only then people who feel like actually answering those things. If you look at like Amazon ads, or Amazon ratings, things like that, or Yelp or something like that, those are typically, I mean, they're not going around and asking anyone to just start giving their star reviews, right? It's usually people who feel that they should respond. And most of the time it's not due to like having a civic duty. Most of the time they want to rate a place or an item based on having strong feelings about that. Like they think it's the best ever, or they think it absolutely sucks and they need the world to know about it. So voluntary response typically yields some biases because it usually only, or I should say it overrepresents people who have strong opinions. And you usually fail to capture the population's moderate opinions. And that leads to the notion of bias. Both methods above are bad because their designs could show bias. And we define bias in a very statsy way as showing consistently under or overestimating the data. I know this is a very statsy way to phrase it, and I suppose it'll come up naturally when I describe some biases that we'll talk about. But be sure to not confuse this with like the colloquial way that you might use bias. Even on the bottom, I have a terminology note, and some AP graders can knock you for this. We don't say that a survey is biased. We say that a survey produces bias in the form of biased data that consistently over or underestimates what the population would actually be. So some of these biases actually have names. They include but are not limited to the following. And these are definitely vocab words that you need to know. One is undercoverage. Undercoverage occurs when some members of the population cannot be chosen in a sample. So suppose there's like a pollster going around for the 2020 election, and they want to know how people in like Milford feel, or who they're going to vote for. So this pollster like whips open the white pages or yellow pages or whatever one has like home numbers of people and starts calling those. I suspect that that would lead to some heavy bias because not everyone has a home phone. In fact, very few people have a landline anymore, and those who do are old. And those who are old typically vote Republican. Not that I have an opinion either way on that. I'm just stating some facts here. That's what the data shows, that older people tend to vote conservative because almost by definition of what it means to be conservative. So what this would do is what this poll would do, as it overrepresents old people, it would consistently overestimate the number of conservative voters because it's not representative of the population. So understand that that's what undercoverage is. And I should also know specifically, I guess, the people who cannot be selected are everyone else who doesn't have a landline, and we would see some patterns in the people who don't have landlines based on generational gaps, on top of other things too. Like, actually, what about homeless people? They don't have home lines because they don't have homes. So they would be underrepresented as well, and if they had a political skew, then that would not be represented in the this particular survey also. So there's also the notion of non-response, which is when an individual chosen for a sample cannot be contacted or refuses to participate. So these two differ, and it's important to recognize why. Undercoverage is when someone cannot be selected in a sample. Non-response is, okay, we did select someone for a sample, but now we can't get their info for one reason or another. So some of you might see this later this year due to your frustration, where usually with the final project at the end of the year after the AP exam, what I have people do is come up with their own study where they have to collect data on their own. What a lot of people decide to do is use Del Val as the population because they think it's nice and easy. And one way that they are able to pull off an SRS, or try to, is that they use student email addresses. I can usually get that for them. I put it into an Excel document. The Excel document rows have numbers, so everyone's numbered already. Easy peasy. You just randomly select numbers from 1 to, we're going to pretend 800, right? And they select however many would be an appropriate sample size. However, what they soon find is that a lot of students just don't answer their emails, which is a bummer. A bummer for them because that leads to biased data. Because suppose the question was like, how do you feel about remote learning or something like that? And you send out 40 emails and you only get responses from 30 of them with those people's feelings. Well, I guess you could carry on and say, I don't need those other 10 that didn't respond. 30 is a big enough sample size. But that's not going to work out too well in terms of trying to represent the population because those 10 who didn't respond may not have responded for a reason, or there might be some pattern to their non-response. So we would get some bias because maybe, for instance, the people who didn't respond aren't particularly tech savvy and they hate the way that this remote learning is going, or they fall on, like, hate to say it, perhaps the low academic end of the spectrum. Or maybe they're very busy and they're athletes and they're like high achieving students and they just don't have time for your silly AP stats nonsense and they don't respond. Something like that. The whole notion about bias is we don't know which way it's going to lean. We just have to be aware of the fact that it might be lurking there. So that would be an example of non-response bias. In this case, it would fail to capture the opinions of those who did not respond to student emails, unfortunately. In contrast to non-response bias, there's also something called response bias, which is when participants respond inaccurately. This could be due to them lying just because they feel bad, or it could be due to them being manipulated, or they could be feeling social pressure. There's a subset of this that you don't need to know, but it's called an acquiescence bias, which is a category of response bias in which people respond to a survey and have a tendency to agree with the questionnaire, maybe because they feel like they want to be in on it, or they feel like they don't want to be confrontational by disagreeing, something like that. There's also like some social stigmas where like there's been studies to show that if it's not what is the word? Jesus, anonymous. Women who are asked about their sexual endeavors may underrepresent the amount of sexual partners they've had, whereas men put in the same situation would over-report the number of sexual partners that they've had. And again, I would proclaim that both of these are due to some social stigmas that might make them feel as though they're judged if they say a number that's too small or too big. So all of these, any incorrect reporting of data would be considered response bias. We also have the notion of being manipulated into answering a certain way. So look at this. Look how these are virtually the same question, or they deal with virtually the same topic, but they yield different percentages. Should illegal immigrants who have worked in the U.S. for 2 years be given a chance to keep their jobs and apply for citizenship? A lot of people said yes. The next one, should illegal immigrants be prosecuted and deported for being in the United States illegally? A lot of people say yes here. Note that this adds up to way more than 100% of people, and they deal with more or less the same topic. It's because a lot of times questions are going to use sort of incendiary or emotional wording, and they're going to use a lot of synonyms that carry connotations. Like maybe instead of illegal immigrant, they say undocumented immigrant, or they just use the word migrant or perhaps refugee, something like these. Or like I've seen some polls say like potential terrorist or something like that when referring to illegal immigrants. I mean, that's going to brew up some emotions that make people answer in particular ways. Also, the way you throw the wording of a question out there can matter. Take this, for instance. On a scale of 1 to 5, how happy with life are you? Suppose I threw that question at you, and then the follow-up was, how many dates have you been on this year? Well, there's a study that showed that asking 1 then 2 yielded no correlation between these two questions, but asking 2 then 1 did. Maybe it makes some people sad or happy to reflect on the number of dates that they've had on any given year, and asking 2 might cause them to change the way or affect the way that they answer number 1. Also, in regards to question asking, I'm not going to say what president this is. However, I did, see, I've said however twice, I'm getting nervous. Please don't think I'm being partisan here. I've seen a poll from the other side doing very recently the exact same thing, which is a bogus set of answers like this. David, the president has asked you to reach out to some of our top supporters for a 1-question poll, and you've been selected. Please take a moment to select the option that suits whatever. The president's job performance has been great, good, okay, other. What about bad? Okay, so this notion right here, we know that this is going out to the supporters of President blank, whoever, right? So most likely they'd be selecting great, good, or okay anyway. But when it comes out that most people here, let's say like 80% have said good or great, so like good or better, that would yield results that I'm sure the president's polling team knows well that this is not actually indicative of the population. However, what they get to do is pass this on to certain news organizations that could say a recent poll from President Blank's polling team suggests that 80% of respondents feel that the president has done a good or great job, and technically nothing they've said there is inaccurate, but look how slimy that is, and look how manipulative that is. What a bummer. Also, I'm just going to throw it out there, presidential polling team blank may not actually have anything to do with whatever president was probably didn't even know that this was happening. So there's a lot of sliminess that we can't particularly stick to one side of the political spectrum or the other. But just be aware that this sort of thing might happen, and it's always important to scrutinize the sources of our data and know how these sorts of things were conducted. Well, that's it. All right, thanks for watching. Stay tuned for more.